Hey, I'm Gloria, an inventor and an aspiring aerospace or computer engineer from Kenya. In this video, I'll be talking about Einstein's theory of relativity, specifically gravitational lensing. So, in simple terms, gravitational lensing is basically the bending of light in space according to an observer, in our case, on Earth. And I'm sure you've heard about lenses, whether it's from your science classes in school or when you're on a safari using binoculars to spot giraffes far away, or even using a microscope to look at tiny objects, or for the curious people there, using a magnifying glass to burn a small leaf. Whatever you heard about lenses, they all work according to how the lens is designed. Though in space, we have a natural lens, and this is gravity. Gravity helps us discover the unknown by becoming our lens. So, gravitational lensing can displace celestial bodies or trick us into thinking that they're more celestial bodies than what they actually are. There's an example of the Einstein's cross, which is a rare phenomenon when one celestial body multiplies and appears to be more than what it is. An example of it is here. I'll edit that in. And basically, in this example, it's one quasar that's behind a galaxy, and this quasar is 10 billion light years away, and it's directly in front of a galaxy that is 400 million light years away. And as you can tell, 400 million and 10 billion, there's quite a distance between them. So obviously the galaxy is closer to us. So the light from the quasar bends because it can't really go through the galaxy, and once it bends, the light that we see from Earth as an observer is at different locations. So one's at the top, one's at the side, like they're opposite each other, and they form a cross. That's why it's called the Einstein cross. This is because the galaxy's gravitational field creates a strong enough force to bend and magnify the light from the quasar, which increases the number of quasars that we see. Einstein's cross is one of the rarest examples of gravitational lensing that we've observed so far, and there's a slightly more common experience called Einstein's ring that is also pretty cool. So it's basically another scenario where light is bent equally from a heavy celestial body or a cluster of galaxies, and for this to actually happen, this image right here, the galaxy, the lens, and the Earth need to be perfectly aligned. If that doesn't happen, another occurrence will happen. So basically, it turns out like that, and it's pretty cool. There are some funny scenarios that have been captured, like this face that I use in the thumbnail, where it's like a smiley face of the galaxy. But so far, there's not much of a difference out of all the images that have been captured. I don't know about you, but this image reminds me of the interstellar image of the black hole prediction that happened 6 years before the first black hole image was captured in 2019. That's a fun fact. I chose this topic as my area, gravitational lensing, because I remember the first time I saw the James Webb Telescope images released, I was buzzing, like I was so excited, and I was mesmerized by the images because they're just so pretty, and like they're out of what I could imagine, because from Earth you don't see such images. Mostly where I live, there's a lot of light pollution, so seeing stars is even a struggle. So now being able to see galaxies, not just stars, and like seeing way deeper into space is just pretty cool, and I just fell in love with the images and I couldn't stop looking at them. So the more I looked at them, the more I realized, and I paid attention to the detail. And this image specifically, I saw that there was a little smudge at the top right image, and I was like, what's that? Isn't this like a high quality telescope? The image could have been edited or refined so that there are no smudges, so that it's as clear as possible, because this is a discovery, this is like history making. So now I researched more about that, and I found out that that is an example of gravitational lensing, and it's basically there's a celestial body next to that galaxy or that other celestial body that is really heavy, so it now bends the light that we observe from the James Webb Telescope. So that's also that's the first example of gravitational lensing that I came across, and it stuck in my head and really sparked more of an interest in astronomy, though I already had an interest from before. So curiosity led the way for me to research more on that, and more research and a ton of YouTube videos led me to creating this video. And I could probably teach a bunch of kids gravitational lensing and they would hopefully understand. Yeah, so possibly Richard Feynman would be proud of me if he was still here. Anyways, thank you for watching. I hope I taught you something new and probably increased or sparked your interest in astronomy. And I hope you love space a little bit more. Ad Astra Per Aspera, and hope you have a great day. Thank you. Bye.